Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on February 5th, 2026, exactly 1 week ago. It introduces BudgetMem, a runtime framework that allows large language model agents to dynamically balance cost and accuracy by routing queries to different compute tiers, achieving a score of 60.5 on the long mem eval benchmark compared to 48.5 for the strongest baseline. The paper is titled Learning Query-Aware Budget Tier Routing for Runtime Agent Memory. And as we'll see later, the efficiency gains on benchmarks like Hotpot QA are really impressive. Alright, Figure 1 lays out the complete BudgetMem architecture. The process starts at the top left with the inputs, specifically the user query and raw history chunks, which avoids expensive offline pre-processing. In the top right, the diagram defines the tiering strategies, allowing the system to switch between simple heuristics and heavy neural models, or to vary reasoning depth. The core pipeline, shown at the bottom, flows from a filter module through parallel extraction modules for entities, time, and topics. Crucially, a shared budget tier router sits at every stage, dynamically selecting a low, mid, or high complexity level for each specific task to balance performance against cost. Well, having established the architecture, Table 1 presents the main experimental results across 3 challenging benchmarks: LocoMo, Long Mem Eval, and Hotpot QA. The top section focuses on the Llama 3.37 dB backbone, where BudgetMem consistently outperforms strong baselines like LightMem and MemoryOS. For instance, on Long Mem Eval, the capacity variant achieves a judge score of 60.5, significantly higher than LightMem at 48.5. The bottom section repeats this evaluation with QN3 Next, where the efficiency is even more striking. On Hotpot QA, BudgetMem achieves a top judge score of 72, while slashing the cost to just 0.22 compared to over 8 for the baseline. So, while Table 1 focused on fixed settings, Figure 2 reveals how BudgetMem navigates the trade-off between cost and performance on the LocoMo benchmark. The graphs plot judge score against dollar cost. On the left and right, the implementation and capacity strategies trace broad orange curves, meaning they can smoothly scale from tight budgets to high-performance settings. In contrast, the middle panel shows that reasoning tiering clusters tightly in the top right corner, acting more like a specialized tool for maximizing quality at a higher price point. Importantly, across all 3 views, the orange BudgetMem frontier consistently envelops the baselines, which appear as scattered points lower down. Okay, while Figure 2 plotted the broad performance curves, Figure 4 now details the specific routing decisions that create them. These charts display the percentage of low, mid, and high tiers selected for the temporal and summary modules as the cost penalty, lambda, increases along the x-axis. Looking at the temporal module on the left, at very low lambda values, the system prioritizes the high tier, shown in yellow. But as cost pressure hits 0.1, it switches cleanly to the green mid-tier. By 0.3, the router begins introducing the low tier, seen in the blue striped section, eventually shifting entirely to this cheapest option as the budget tightens. Alright, while the previous figure showed the final routing choices, Figure 3 demonstrates why the reward scale alignment mechanism is essential to get there. The 2 charts plot the judge score on the left and cost on the right, as a cost penalty lambda increases. Notice the orange line, which represents the system without alignment. It collapses almost immediately, driving the score and cost to the bottom even with a small penalty. In contrast, the blue line maintains a smooth, gradual slope, proving that alignment is necessary to prevent the policy from simply choosing the cheapest option regardless of quality. Wrapping up, 2 takeaways stand out. Dynamic, runtime routing significantly improves efficiency over static memory systems, and modular budget tiers offer precise control. This approach shifts the paradigm from build once to decide on the fly, making large-scale agent deployments far more practical. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.